So in a previous video, we saw that a kernel is an essential part of an operating system. When you boot up your computer, the first thing that kicks into action is the kernel. Think of the kernel as an ultimate traffic controller, managing how your system's resources like CPU, memory, and storage interact with applications. If you look at the whole setup, at the very core, you have got the kernel, the main component of the OS. Then comes the OS itself, which builds upon a kernel and often comes with a layer of graphical user interface. This is what we see and interact with by clicking buttons and navigating through the menus. GUI involves comparatively more steps to send a request and receive a response from the kernel. Meanwhile, a shell allows you to directly interact with the kernel. It's an interface between you and the kernel. Let's see an example of viewing the contents of a small text file to understand both the workflows. In a most simplified overview of the GUI workflow, to view the contents of a text file, you would first double-click it to open the file. The graphical server like Wayland or X server detects this click event and forwards it to the file manager. The file manager then uses APIs like GTK, requesting the kernel to open the text file with a default text editor application. Whereas in the CLI workflow, if you know the command, you just type it into this shell, which makes a system call to the kernel to execute the command and displays the file contents. As you can see, the CLI way is almost a direct instruction to the kernel. So shell is your direct line to talk to the kernel, allowing you to execute commands, manage files, and control your system, often without needing the GUI. In this series of videos, we will start with a few basic commands to manage the files and directories, followed by text manipulation and redirection. By the end, we will write simple bash scripts and see a few real-world examples. Right? Let's get started. The default shell in most of the Linux distros is Born Again shell, or simply bash. We can access it using terminal emulators. In Fedora, the default terminal is Tixis. Earlier versions of Fedora and DEs like Cinnamon use GNOME terminal, whereas KDE Plasma uses console. We can check the default shell by typing echo $0. This prints out the location of bash or just says bash. Let me remove the OMP theme so that we can have the default look. If you have GNOME terminal, you can open it by pressing Ctrl-Alt-T. If Tixis is not opening with that shortcut, you may have to configure the keyboard shortcuts in the settings. Along with the terminal window, I will keep a file manager window open on one side so that we can see what's happening while using the terminal. Before starting, let's have a look at the directory structure in Linux. At the top level, we have root. We denote it with /character. All other directories are child directories of root. And most of these store system files, application binaries, log files, etc. We may need root privileges to access some of these directories. I explained about root privileges and how sudo allows us to get root access in an earlier video. We may not touch these directories in this video unless necessary. One of the subdirectories of root is home. This is where all the user data is stored under a separate subdirectory with the user's name. If there are multiple user accounts, each will have a separate subdirectory in home. I have 2 user accounts on my system, so there are 2 subdirectories. When we enter our accounts directory, we can see many subdirectories. This is our account's actual home directory. Whenever we open a file manager, we are always inside this directory. Now let's check the terminal window. When we open a terminal window, we have a few things displayed by default. The part before the colon displays the username, followed by the host name. We can modify the host name from the settings. Whereas the part after the colon character displays the path of the current working directory. Here we have tilde, which is a single character representation of the user's home directory. That means whenever we open the terminal, we are in our home directory similar to our file manager. Then comes the dollar symbol, which is a prompt. Whenever you see a prompt, you would also see a blinking cursor, which means the terminal is ready to take commands from the user. Now we know that we are in our home directory. To see the full path of this current directory, in the file manager, we can click on the path bar and see it. So the path starts with /, which means root, and then the home directory, and finally the user's name. Note that each subdirectory is also separated by a slash. So in this video, whenever we are representing the root directory, we will refer to that as / or root, whereas for the separators, we will just say slash. Now, to see the path of the current directory or current working directory in the terminal, we can use the command pwd, which is short for print working directory. We can see that home directory has many subdirectories. In the terminal, if we want to list out the contents of the current directory, we can use a command called ls. Let me make the colors a bit brighter. If we want to see additional details regarding the contents of the directory, instead of just listing their names, we can add parameters or flags, or in simple terms, options to the ls command. So to see details of the contents, we have to add -l to the ls command. Note the gap between the command and the flag. Now it displays more information about the contents. We will see what these details are a bit later. So what flags can be used with ls? To know that, we can use the man command, short for manual. Type man ls to see the available flags or options. We can also use the --help flag with the ls command. Note that these flags are different for each command. As we can see, we have a long list of options for ls. What about our first command, pwd? It has only two options. Coming back to the ls flags, we can see that some of these have two variations. The single dash variation is the short version, whereas the double dash variation is the long version. If available, you can use either of these variations. So adding the single dash a or double dash all flag means that ls will not ignore the entries starting with a dot. What does this mean? What are these dot entries? Let's try adding the double dash flag to ls. So along with our earlier items, we can also see additional entries starting with a dot. Why are these not visible in our file manager? Because these are hidden items. Click on the file manager window and press Ctrl H to view or hide the hidden files. Now we can see the dot items. Either it's double dash all or single dash a, both give the same output. Note these single and double dot entries. We will come to these in a minute. We have seen how a flag enhances the ls command's capabilities. We have used two flags, -l and -a. Can we combine these flags? Certainly. We can use multiple flags at a time. So if we want to include hidden items along with the long list, we can use both the -a and -l flags. We can also add both the flags with just one dash, like ls-al. Now we are seeing all the contents in our current directory, including hidden files, in the long list format. By the way, you can navigate through the previous commands using the up and down arrow keys. In the help output, we can also see how the command can be used. Here, the options and file are enclosed in square brackets, which means these are not mandatory. We have already seen that ls works as it is. and doesn't require any additional options or file names. So by default, it lists the contents in the current directory. We can give a directory's path to ls to see its contents. In bash, a single dot represents the current directory. So if we type ls dot, the output is same as earlier. Now in my downloads directory, I have a few items. To view its contents, I can type ls downloads or ls./downloads. Both give the same output. If there are no contents in a directory like my music folder, then it won't return anything. So now we are in this directory, and if we want to look at the contents of its parent directory, we can either type the full path if we know it, which is /home, or we can use double dots. So double dots represent the parent directory of whichever directory we are currently in. Till now, we have encountered 4 representations for directories: /, tilde, single dot, and double dots. So ls dot lists the contents of the current directory. ls double dot lists the contents of the parent directory. ls tilde lists the contents of the user's home directory. As of now, it is the same directory as we are in. And ls / lists out the contents of the root directory. Further, in the help output, we can see 3 dots after options and file, which means we can provide multiple options and paths to ls. Just like giving multiple options to the ls command, we can list out the contents of multiple directories at a time. So if we type ls downloads space documents, we can see the contents of both downloads and documents directories. But be careful while using spaces. If we type ls downloads /, these are the contents of the downloads directory alone. But if we type a space before / by mistake, then we are dealing with 2 different directories. It prints out the contents of downloads and root. Right. Another useful command to see the actual directory structure is tree. Without any flags, the tree command prints out all the files and subdirectories of the current directory recursively. We can add flags like -d to show only the directories, or -L to restrict the levels of subdirectories, like tree-L1, which displays the first level contents and is similar to ls but with a tree structure. Note that L flag takes an argument or a value. If the value is not provided, it throws an error. There are many flags for the tree command. You can explore its help output. Now let's have a look at the details or the metadata of our listed contents. In these columns of data, the first character represents the type of that item. Here we are seeing D, which means it is a directory. The next 9 characters represent the item's permissions for the current user, the user's group, and others. Groups are useful when we have multiple users on the system. We can categorize them into groups so that they can have specific privileges over others. For example, if we have 5 users and we want only 2 of the users to access a directory, we can create a group and add these 2 users to the group. Then set the same group to that directory. By default, a group gets created with the same name as that of the user. So here, the first 3 characters say that the current user, that is your account, has read, write, and execute permissions for this directory. The next 3 characters indicate that the current user's group has read and execute permissions, whereas others have read and execute permissions as indicated by the final 3 characters. Then we have a dot character for some of the items. This is specific to the Linux distros using SE Linux security. The dot means that the item is SE Linux secured. If you are using Ubuntu, you may not see this character unless you have installed and enabled SE Linux. The next column indicates the number of hard links that the item has. There are 2 types of links in Linux, hard and soft links. It's a bit out of scope to explain these in this video. If you are interested, you can go through the linked resource. Then comes the username and group name. As I mentioned, by default, both have the same names. After that, we have the size of that item. Then we have the date and time columns. It is the date and time that the item was last modified. Well, you know the last column, it is the name of that item. We can see that all visible items in our home directory are directories. If we add both L and A flags, we can see a little bit of variation since we have files as well. The files have dash as the first character. If you look at the size column, it displays everything in bytes. So if we have large files, obviously the size will be large and may not be readable. What we can do is we can add an extra flag, H, to make it human readable. Now we have a converted form of the size column. Let's take a look at the root directory. Now we can find additional types like a soft link or symlink, items having more than one hard link, varied permissions, also a new type of permission T, which represents sticky bit, again out of scope for this video. Also note that we have a different color for each item type. Right, that's about the metadata. Till now we have always been in the home directory and have never moved away from it. So the next command is used to navigate through the file system, which is cd, short for change directory. It takes a destination path and changes the current directory to the given destination. So if we want to move to the documents directory, we can type cd documents. Note the change in the current directory's path. Now to go back to the home directory, which is a parent directory to our current directory, we can simply type cd double dots. We can also move to sub-level directories in one go. Let's create a directory in the documents directory and a few subdirectories inside it. We will see how to create directories using the terminal after this section. Check the structure by typing tree in the terminal. So to navigate into one of these subdirectories, we can start typing the full path like cd documents / doc sub / sub1. Now in whichever directory we are, if we want to navigate back to the home directory, we can either use the cd tilde, where tilde represents the home directory, we already know that, or just type cd. Typing just cd always takes us to home directory. There is another shortcut that can be used to switch back to our previous directory. So we were previously in the newly created sub1 directory. Instead of retyping the whole path, we can use cd dash to toggle between your previous and current directories. Let's go back to our home directory and look at another useful shortcut. While typing the paths of directories, hitting the tab key tries to autocomplete the name of the directory or file if it exists. Now to navigate to the music directory, we can start typing cd m and then hit tab, and it will autocomplete the directory name for us. Note that this worked because there is only one directory which is starting with the uppercase M. Let's say we want to navigate to the downloads directory. If we type cd capital D and then press tab once, this will not autocomplete because we have 3 directories starting with the letter D. But if we hit the tab twice, it will display all 3 directories, indicating that we have to choose one of those. Then when we type O, it still won't autocomplete as we have 2 directories starting with DO. So autocomplete works after typing cd do w and then pressing the tab key. What if we type cd uppercase A and hit tab once or twice? It does nothing as we have no file or directory starting with A. The tab key is really helpful when we are exploring the sublevels. So instead of typing the full path, we can start hitting tab. When there is only one file or directory, hitting tab will automatically fill that for us without typing anything. cd doc tab tab and then tab underscore 1. We have been moving downwards into the sublevels. Now let's look at the other way around. If we want to move back to the documents directory, which is 2 levels up from here, we can type cd double dots slash double dots. You can keep adding the double dots and move upwards. However, it may become messy as we are not using any directory names. And you may also reach the top of the tree and can't go any further. Let's go back to the documents directory. Now from here, if we want to navigate to the downloads directory, we can type cd double dots slash downloads. Try going back to one of those subdirectories in the documents directory right from here. So we can type whatever the paths we have been using till now with the cd command are called relative paths because those were relative to the current directory. In relative paths, always the current directory is the starting point. On the other hand, we have absolute path. Absolute paths always start with forward slash, that is root. So from the current directory, if we want to go to the downloads directory, we can type cd double dot slash double dot slash double dot slash downloads, which is a relative path. Or type cd forward slash home slash username slash downloads, which is an absolute path. The pwd command always outputs the complete path, which is an absolute path. Earlier, we created new directories by using the right-click menu in the file manager. Now let's see how to create directories using the CLI. To create a new directory, we can use the command mkdir followed by the name of the new directory. Unlike ls and cd, mkdir should be provided with the directory name. If we don't give the name, it will throw an error. However, we can give multiple names to create multiple directories at a time. We can also make subdirectories within a directory from the current location. We can use all the relative and absolute path knowledge to create directories at any location. Note that we are making subdirectories within existing directories. We have come back to our home. Now let's try to create a new directory and a subdirectory within it at the same time. Will it work? No, it throws an error. To make this work, we have to use the p flag. It creates a subdirectory and all its parent directories. Well, we have made so many empty directories which are of no use, so let's remove them. To remove empty directories, we can use rmdir followed by the directory name. Note that it can't remove directories with contents. It works just like mkdir but in the opposite way. So to remove the new directory, we can type rmdir and the directory's name. We know that all the newly created directories are empty. Can we delete all of those? Let's try. This deletes only test4 because the other directories are not empty. They have subdirectories. So let's delete the empty directories along with their parent directories using the p flag, just like mkdir. At this stage, let me introduce you to the wildcard character asterisk. Let us create a few test directories like earlier. mkdir, test1, test2, test3. Now, these do not have any subdirectories. So if we want to delete these 3 directories at a time, we would usually do rmdir, test1, test2, test3. But we have common characters in our directory names and only the last character is different. So we can use the wildcard character and delete all 3 directories by just typing rmdir test asterisk. So a wildcard represents any character as well as any number of characters. We have two directories with main underscore as the starting part. Let's create one more nested directory. If we check the structure of these main directories, we can see that one of the directories has two sublevels, whereas the other two have one sublevel. If we use rmdir -p main underscore asterisk slash asterisk, we can delete those with one sublevel. And rmdir -p main underscore asterisk slash asterisk slash asterisk to remove the other one. If we use just the asterisk, it would match all the characters. So if we had multiple subdirectories in the main dir, it would delete all subdirectories. So be careful while using just the wildcard. We can also use a wildcard at any position in the name. We just have to find the common characters. Now we have two directories which have a common underscore character. We can type rmdir asterisk underscore asterisk to remove these two directories at a time. Okay, that's about creating and removing directories through the command line. Now let's deal with files. We will do that in a new directory called testdir. Let's create that and navigate into it. To create new files, we can use the touch command. The actual usage of this command is to update the access and modification times of an existing file. However, if there is no existing file with the name we have provided, it creates a new file. We will also look at creating new files while using standard streams. Now, let's make a copy of our text file. We can do that using the cp command. The cp command needs two things: the item which we are copying and where we are copying it to. That is the source and destination. Let me create a new directory called copied content and then make a copy of the test file in it. Now we can see a copy of that file in the new directory. By default, the cp command won't display any output unless there is an error. So if we try to copy a non-existing file, it will throw an error. Further, we could also give a different name while copying. We can add the v flag to make it more verbose. Right, we copied files. But what about the directories? Can we copy those as well? Let me make a new directory named new dir. Now, if we type cp copied contents new dir, it will warn us to use the R flag and it won't copy anything. So as it says, to copy directories and its content, we have to use the recursive flag. Note that by default, cp overwrites files and directories which have the same names. That's about copying files and directories. Now let's see how to move files and directories from one place to another. Just like the copy command, we can move files by providing the source and destination to the mv command. Let us create a new directory called moved content and then move the test file into it by typing mv source file and the destination. Let's move one of the test files from the copied contents directory to the current directory. We can move the directories as well with the move command. But unlike the copy command, we don't need the recursive flag. The move command can also be used to rename files and directories. Now let's delete the files and directories. We know that rmdir removes the empty directories and it won't work on files and directories with contents. So the command we can use to delete the files and non-empty directories is rm. We will first delete the text file from the current directory. Let's delete one more file from the copied contents directory. Now the copied contents directory is empty. Since this is a directory, we cannot delete it with rm as such. Instead, we have to use the recursive flag to delete directories with or without contents. We can also remove empty directories with rm using the d flag. So basically rmdir is rm with d flag. Now let's delete all files from the moved and renamed directory. Since these are only files, we can type rm moved and renamed /*. Now let's delete all files and directories from the current folder. We will also add the verbose flag. That's it. Whatever we have created till now is gone permanently. Note that the content deleted using rm cannot be recovered, so be careful. In the next video, we will see how to manipulate text files and also look at the concept of redirection. Thank you.